A very good afternoon, class. So, as you all know, we have already started with the 8th chapter of Maths 2, that is probability distribution. And we have finished in the last lecture with exercise 8.2, which dealt with probability distribution of a continuous random variable. Now, today, class, we'll be focusing on completing the miscellaneous sums, that is part 1. Out of that, we had finished question number 1 to 12, which were basic, and were dealing with exercise 8.1. Now today we'll be completing the sums related to exercise 8.2, that is probability distribution of a continuous random variable. So coming to sum number 13, 14, 15, 16 and 17. So with these sums today we'll be completing with chapter 8 fully with all the sums and exercises completed. So coming to sum number 13. Suppose error involved in making a certain measurement is a continuous random variable x. With PDF, question is given to you. As f of x is equal to k into 4 minus x square, with the variables, the functions, the condition put on is -2, less than x, less than 2, 0 and otherwise. Now, if you remember class, we had already covered this particular same sum in exercise 8.2. So you can refer to exercise 8.2 because it is the same which has been put here again. So I'm not solving this 13th sum as we have already finished it in the exercise. Coming forward with the next sum, sum number 14. The PDF of the random variable x is given as f of x is equal to f of x is equal to 1 upon 2a, 0 less than x less than 2a, 0 otherwise. You have to prove that LHS is equal to RHS, that is probability of x less than a by 2 is equal to probability x greater 3a by 2. So let's see how the sum is solved. The PDF of a random variable is given in the question. F of x is equal to 1 upon 2a and the conditions put forth was 0 less than x less than 2a. So over here we'll first start with the LHS part, that is probability of x less than a by 2. So less than a by 2 is nothing but we'll take the condition 0 to a by 2 because that's the condition which is put forth. So integration 0 to a by 2 f of x dx. So integration 0 to a by 2 f of x is given as 1 upon 2a dx. Now as 1 upon 2a is constant, I will remove it outside the integration sign and write it as integration 0 to a by 2 1 upon 2a integration 1 dx. Now integration of 1 is nothing but x. So we get the answer 1 upon 2a x 0 to a by 2. So now we'll put the upper limit a by 2 minus the lower limit 0. So 1 upon 2a into a upon 2. So a gets cancelled. I'm left with 1 by 4 which is point number 1. So I hope you all are clear with the LHS part. Continuing forward, now let's see how the right hand side is solved. Probability x greater than 3a by 2. Now greater than 3a by 2 means we'll start from 3a by 2 to maximum we can go up till 2a. F of x dx. So integration 3a by 2 to 2a 1 upon 2a dx, the same pattern. I will take 1 upon 2a outside and integration of 1 will give me x. And the integrals will get transferred to the right hand side. 3a by 2 to 2a. So on solving that I get 1 upon 2a bracket open 2a minus 3a upon 2. On cross multiplying I get 2a into 2 which gives me 4a minus 3a upon 2. So on opening the bracket 4a minus 3a gives me a by 2. Again a gets cancelled and I'm left with 1 upon 4. And I name it as step number 2. So class, as you must have seen, the conclusion from point number 1 and point number 2 is LHS is equal to RHS. And that is what we had to prove class, sum number 14. So from 1 and 2, I can conclude that left hand side is equal to right hand side. Okay. Coming forward to the next sum, that is sum number 16. The PDF of a random variable x is given by f of x is equal to k upon root x, and the condition put forward is 0 less than x less than 4. Determine k, the CDF of x, and hence find probability x less than equal to 2 and probability x greater equal to 1. So again, here they have told us to find out 4 things, but first of all, they are telling us to find out the value of k. Now, to find out the value of k when it is a PDF, class, remember the formula? For a PDF of a random variable, if the function is already a PDF, we can say that integration minus infinity to infinity f of x dx is equal to 1. So, based on this formula, we'll be finding out the value of k as follows. So, as the condition put forward was 0 less than x less than 4, 1 is equal to integration 0 to 4 k upon root x dx. K being a constant, I'm removing it outside the integration sign. So I'm left with 1 is equal to k integration 0 to 4 1 upon root x dx. Now the formula doesn't exist for only root x, but integration of 1 upon root x is nothing but 2 root x. So 1 is equal to k into 2 root x 0 to 4. So now k and 2 both are constant. So 1 is equal to 2k into root x 0 to 4. So first I will substitute the upper limit and then the lower limit. So 1 is equal to 2k bracket open root 4 minus 0. So root 4 is nothing but 2. So 1 is equal to 2k into 2. 1 is equal to 4k. So the value of k is nothing but 1 by 4. So I'm done with the step number 1, that is finding out the value of k. The next they are asking me is to find out the CDF of x. Now in order to find the CDF of x class, what was the formula which we studied last time? So for a CDF, capital F of x is equal to integration minus infinity to x. F of x with respect to dx. So f of x is equal to 0 to x 1 upon 4 root x dx. Now from where did I get 1 upon 4 root x class? If you remember, the value of question was f of x is equal to k upon root x. Now we got the value of k from point number 1 to be as 1 by 4. So 1 upon 4 upon root x will give me 1 upon 4 root x. 1 upon 4 divided by root x. So 1 upon 4 into 1 upon root x will give me 1 upon 4 root x. So in this way, I get integration 0 to x 1 upon 4 root x dx. So that is why I've written from 1. So in the similar manner, f of x is equal to 1 upon 4. I will remove outside as it is a constant. 0 to x integration 1 upon root x dx. So what is integration of 1 upon root x class? It is nothing but 1 upon 4 into 2 root x 0 to x. So I'll remove 2 outside. So this will become 2 upon 4 root x 0 to x. So f of x ka function, the CDF formed gives me root x by 2. So I hope you all are clear with the second stage as well. Now moving on to the third stage. They have told us to find the value of probability x less than equal to 2. So now less than or equal to 2 they have told. So directly I can take f of 2 over here. So as you can see, f of 2 we got recently on upper side. Point number 2 was root x by 2. So as you can see upside over here. So I have got the value of f of x to be as root x upon 2. So f of 2 will be root 2 upon 2. Now you can break up 2 and write the value of 2 as root 2 into root 2. So root 2 and root 2 gets cancelled and you're left with 1 upon root 2. In the similar manner, you can find out the fourth stage, that is probability of x greater equal to 1. So again, we can consider they have told equal as well. So directly I'll put f of 1, which is root of 1, which gives me again 1. So the answer is 1 upon 2. So with this, sum number 16 gets over. All right. So finally, moving on towards the last sum of this particular miscellaneous exercise, that is sum number 17 and also of this particular chapter. Let X denote the reaction temperature in Celsius of a certain chemical process. Let X be the PDF, which is given as f of x is equal to 1 upon 10, and the condition put forward is minus 5 less than equal to x less than 5. 0, otherwise you have to find the probability of x less than 0. So let's have a look how to solve this particular sum, class. So as you can see, the PDF of a random variable x is given as f of x as 1 by 10, and the condition put forward is minus 5 less than x less than equal to 5. Now probability of x less than 0 will be minus 5 to 0. So f of x dx. So the value of f of x they have given is 1 upon 10. So integration minus 5 to 0, 1 upon 10 dx. So as 1 upon 10 is a constant, I'll remove it outside. So integration minus 5 to 0, 1 dx. Integration of 1 is nothing but x. So 1 upon 10 into x minus 5 to 0. So first I'll put the upper limit, that is 0 minus of minus 5. So minus into minus will give me plus 5. So 1 into 5 upon 10 on cancelling, 5 ones are, 5 twos are. I get the final answer to be as half. So with this, class, probability of x less than 0 is nothing but 1 upon 2. Now we have finished with the lesson as well as all the exercises and miscellaneous. But before I wind off, class, let's do a quick revision of what all topics we covered so that it will help you all out when you again go through the chapters. So in short, I've prepared a quick revision section for you all wherein we can revise the formulas which we have covered in all the exercises up till now. So as you can see in exercise 8.1, we basically covered 3 different types of concept. Number 1, how to make a probability distribution table. So whenever you are solving any sums related to probability, class, always see to it whether making a table is possible or not. And probability distribution table is nothing but making 2 columns, that is one side will be x and the other side will be p of x. So that should be the 2 columns. The next topic we saw was, can a function be called as a PMF or not? Probability mass function. So these are all topics related to discrete random variable, class. And what was discrete random variable? All things which you can count. All right. So 2 conditions should be satisfied in order for a function to be a PMF. The probabilities of x should always be greater or equal to 0. So all the probabilities of x, that is, which you can see in this particular column, it should be either 0 or greater than 0. And the total of this particular column of p of x should be equal to 1. The next topic we saw was calculating E of x, that is mean of x or expected value of x as it is called, and variance of x, that is V of x. So when you have to calculate in the form of a table, class, for E of x, we require to prepare 3 columns, that is x, P of x, and the third column is x multiplied by P of x. So the formula for E of x is total of summation of x into P of x. When they are asking you to find out variance of x, for variance of x, you need to prepare 5 columns. So it is x, P of x into P of x, then x square and x square into P of x, that is column number 2 multiplied by column number 4. So the formula of variance of x becomes ex square minus ex the whole square. And also those who were finding it difficult, for them I had given a shortcut, that is total of column number 5 minus total of column number 3 ka square. So those who can't remember the formula can write that way, but yes, don't expect to get full marks. In order to get full marks, you have to write proper formula, which is ex square minus ex the whole square. So with that, we finished with the first exercise consisting of 3 different types of sums. Next, we started off recently with exercise 8.2, including PDF and CDF of continuous random variable, those which are measurable. So in order to find out whether it is a PDF or not, the condition which should be satisfied should be minus infinity to infinity integration f of x dx should be equal to 1. Then we can call the function to be as a PDF. For a CDF, which is also called as capital F of x, integration minus infinity to x f of x dx is equal to capital F of x. So if I split it into 2, it will become integration minus infinity to 0 f of x dx plus integration 0 to x f of x dx. Then you can say the following function becomes a CDF. The function of CDF is ready to solve. Then we had already done with exercise 8.3, which was dealing with binomial distribution. So whenever the sum related to binomial distribution will arise, that is word problem, so you will have to find out 3 alphabets class, that is N, number of times, P representing success, and Q which represents failure. The formula for P is 1 minus Q and the formula for Q is 1 minus P. The formula for binomial which can be used is probability of x is equal to x, NCx into P raised to x into Q raised to N minus x. Also in a binomial, mean is equal to NP and variance is equal to N multiplied by P multiplied by Q. Always in binomial distribution, mean will be greater than variance. So in a binomial, mean ka formula is NP and variance ka formula is NPQ. So with that, we finished with exercise 8.3. Next, we move forward to exercise 8.4, Poisson distribution. For Poisson distribution, one thing you have to keep in mind, words such as mean, average, per, PER, they all represents Poisson distribution. Also, the value of e raised to minus m given in the bracket will give you a hint that it belongs to Poisson distribution. So the formula which we used in Poisson distribution was probability of x is equal to x, m raised to x into e raised to minus m upon x factorial. So these are all the formulas which you have to keep in mind related to chapter number 8. Also in Poisson, mean, variance and m, the parameter, all are equal. At times, we can find the value of m by using mean ka formula NP, and that is only possible when the value of n is too large and the value of p is too small. Like for example, in a lot out of 100, 3% products are defective. So m is not given, but the value of m comes to 3. How? 100 multiplied by 3%, 3 upon 100. So 100, which was n, multiplied by possibility, the probability given 3%. So 100 into 3 upon 100, answer is 3. So with this class, finally, we are winding off completely with chapter 8 of Maths 2 probability distributions. So you can go through all the videos of this chapter related, and if any doubt, please let me know in the comment section. Till then, take care, stay safe, and practice all the sums in your notebook. Okay, class, till we meet again, take care and stay safe. And thank you so much for listening to me. I stop here for today.